You know? No, it's working. All right. Send those gifted subs. Get the hype train going in the chat. Okay. Forces. So if you're doing a physics problem about forces, it's 95% of the time you can just break it down into step one is to draw the force diagram. Draw force diagram. And then step two is to apply this formula. Okay. Technically, if I want to be really technical, I put these little arrows. Why would I put little arrows over those? They are vectors. They have direction. All that means is if the net force points that way, that's the direction the acceleration points. It's just like velocity. It's a vector. It has direction. Most of the time, you can just identify the direction that you care about, and then you don't have to really think about them as vectors. You can just think about them as numbers. And then three, maybe an asterisk. Sometimes you're just asked to find the acceleration, or you're finding the force, whatever. But sometimes you got to use some kinematics. Okay. Now, maybe I'll put a little arrow here because sometimes like you start off with this and you go to this occasionally, but basically this is just all you have to be able to do to solve any of these questions. And usually this is the thing people get hung up on. They go, I found the acceleration, but I'm rusty on using kinematics. So just keep that in mind. There's some kinematics from time to time. But we're mostly just focused on these. Let's throw out one quick example, because you'll notice that these are all very similar, or they're all kind of like, they all just follow the same process. Well, let's pick a random one. About 12. I think today I might cover a couple of these, and then we'll have some time just to work through them. You guys can come up with your own questions, but just a quick little demonstration. Maybe let's do 11 then. Let's do 11 and then 12, because that'll kind of illustrate what I'm talking about. Let's do 11, and then we'll do 12. Watch, you'll like these. They're actually quite easy. 11 says there's an 8 kilogram block. Here's my block. 8 kilogram block. It's at rest on a frictionless surface. So here's my surface. A rope pulls it to the left with a 30 Newton force. So you go 30 newtons. And another rope pulls it to the right with a 70 Newton force. There's my 70 Newton force. Draw a force diagram and find the acceleration of the block. Okay, is my force diagram complete? Not technically. It kind of is, because the more you do these, the more you start being like, well, I know these technically exist, but I don't really care about them. Let's throw them in there just for a good measure. How big is this? What's the magnitude of this vector? How do I find it? 9.8 times 8. So this turns out to be 78.4 newtons. That's the force from gravity. Does anyone remember the fancy name for this? For this upward force? I could say force from the surface. It starts with an N. Normal force, yeah. So a lot of times you'll see this written as F sub N. So the normal, remember, normal just means perpendicular pretty much. Okay, so there's my force diagram. The arrows aren't to scale, but it's not the end of the world. I'd try to at least, like, if there's two vectors that are opposing each other and one's bigger than the other one, make that arrow bigger. Makes it easier to read. But as far as, like, these ones, it's not like super critical. Okay, anyway, what's the net force?
Right.
So use this formula. The net force is 40.
Yeah.
Does everyone understand that? Because there's 70 this way, there's 30 this way. These guys cancel Lancely. So it's 70 minus 30. Are we sure everyone understands that?
Yes.
So don't overcomplicate it. It really is that simple. You just look at any place. It's going to get more complicated. Don't worry. You're like, no, I want it to be complicated. For now, it's very simple. They point in opposite directions. You just subtract them. Okay, so you get, so F net's 40 newtons. The mass is 8 kilograms. So the acceleration must be 5 meters per second. That's pretty painless, right?
Wait, I remember you saying the net force is like the combined force.
Mhm.
So is that the definition, like combined force?
Combined could be a little misleading because the net force is, the word net is probably the best word I know because net would be like, so say, here's a good example. Like, let's say you have a company and you just made $100 in revenue and you had like, $40 in costs. I mean, you could talk about how like the total flow in and out of the company was $140. And that in some sense, although most of the time we talk about the net would be $60.
Right.
So in this case, what you do is you say, consider this the positive direction and this the negative direction, and say those are forces opposed. So this is basically 70 plus negative 30.
Okay.
So
Right.
net, I don't know, can anyone else think of a different word other than net to describe? I don't like the word combined because if this were me and I was getting pulled by 70 and 30, from my personal perspective, I would think that would suck because you're like, oh, that's 100 newtons combined. If I'm talking about the word combined, I'd probably talk about, am I going to get ripped apart? My arm's going to be severed from my torso, that kind of thing. So, but for the block, yeah, we're talking, what's the net? Okay, 12 is similar. You got a 20 kilogram block is at rest on a frictionless surface. Here's the block. 20 kilograms. Rope A pulls it to the left. So here's the force from rope A. And rope B pulls it to the right. And we know that the tension in rope A is 100 newtons. Okay. And then the block experiences a rightward acceleration of 4 meters per second squared. So we know the acceleration is 4. Okay, so what do we do now? So we write the formula, F net equals ma. We're going to find the net force. So write the formula. And then there's sort of two approaches here. One is to replace this variable with an expression like, you see how I could write, oh, by the way, does it say, this is important. Is it accelerating to the right or to the left? So which direction is the positive direction then? Let's call this the positive direction and this the negative direction. Okay? So would the net force be this minus this, or would it be this minus this? Is it B minus A or A minus B? It's B minus A. Now, so what I'm saying is I could write right here, I could write F sub B minus 100. But I find a lot of people prefer to do this. Just keep it as F net. What's the mass? 20. What's the acceleration? 4. So if I know that the net force has to be 80 newtons, then just, I don't know, kind of number sense wise, how big does this vector have to be? 180. So the answer is 180 newtons. That make sense?
Mhm.
Now, here's what I was talking about a moment ago. You might prefer to go, well, I know that F net is going to end up being F sub B minus 100. See how you could have done that?
Mhm.
And then you're solving it directly in your formula. So it's up to you. It's your preference. How do we feel about that?
Did you do 14?
14? Yeah. All right, you tell me what's going to separate this a little bit from these two. What does 14 involve?
Well, your experience of acceleration takes like a period of time.
Right. So looking at this, 14 is going to involve what? Kinematics. So that's the only difference. So we're going to basically take the exact same approach, but we might have to use a little bit of kinematics in the process. I don't like writing this as a numbered list. I mean, so much. It's more of like maybe like a triangle, because they can happen in any order. Like on this problem, I'm thinking, like, so this block goes from rest up to 8 meters per second in 2 seconds. So what does that tell us?
This is acceleration.
Well, the acceleration is 4. Right? And so really, if we take that first step of being like, okay, the block is going from a velocity of 0 initially up to a final velocity of 8 over a time period of 2 seconds, all that really I can just boil down into this. The acceleration was 4. Everyone okay with that? This is on 14, of course. And so now that we have this, we use kinematics. Let's use this. So force diagram goes, I don't know the mass, so I'll put a little m in there. Frictionless surface. He's pushed to the right with 100 newtons of force. Those cancel out. I don't really care about them so much, right? I'm still going to put them on the diagram because they're there, but I don't really care about them because they cancel out. So what can I write? F net equals ma, right? What's the net force? 100. What's the mass? We don't know yet. What's the acceleration? We calculated it. It's 4. And so 25 what? Again, the beauty of SI units. Yeah, I'm actually dividing newtons by meters per second squared. But since those are all SI units, I know that it should work out to kilograms, which it does. So if you think about, what's a newton divided by a meter per second squared? Well, a newton, if you remember, was defined as a kilogram times a meter per second squared. So when you divide a kilogram times a meter per second squared by a meter per second squared, banana, kilogramma. Okay, so does all make sense? Sweet. All right, guys, we got some work time. We made good time on that video, so lit. Thanks for the gifted subs. Who should we raid?